Okay, here we're going to talk about how to graph reciprocal functions. These are often they often seem like confusing topics, but they're really not. We just have to come up with an actual process in order to master them. So we're going to pretend that the question just asked us to graph this red function here, and we want to recognize that this is a reciprocal function. So what does that mean? We're basically looking for 1 divided by something with x's in it. So this meets that criteria. Now, if we're just asked about that, we always want to focus on that something that's on the bottom and actually graph that first. So in this case, the question actually gave us that function. You can see this x minus 3 squared is actually found on the bottom of this reciprocal function, but we are going to graph just that blue function first, because it's going to make it much easier to graph reciprocals once we already got the base or the original function. So let me show you what I mean. Hopefully we remember that x minus 3 squared, and I'll do this in blue because I'm going to graph this one first. X minus 3 squared is just a parabola with vertex at 3, 0. So it looks like this. That's sort of your base parabola. Great, vertex at 3, 0. That's perfect. That's the original. Now to graph the red function, which is exactly what it asked for. So 1, 2, 3, do something like that. Notice that we're graphing 1 over this function. So this function in blue is, you could think of that as your f of x, and we're graphing 1 over f of x. So 1 over f of x looks like 1 over y. So all we're going to do is keep all of the x values the same from this blue function, but divide the y values underneath 1. So do 1 divided the y values. Couple things we want to focus on. First, because if y is 0 in this equation, we cannot divide. That's going to say, okay, we can't have those points where y is 0. Y is 0 is found at the x-intercepts, so we're going to put a vertical asymptote through the x-intercepts. So that's the first step. So I'm going to put a vertical asymptote through the x-intercept here, which is where it crosses the x-axis. Again, that should make sense because 1 divided by 0 cannot be calculated. Second, because we're doing 1 over y, we know 1 over 1 equals 1, and 1 over negative 1 also equals negative 1. So we are going to keep the points where y is 1, where y equals 1 or negative 1. So where are those? I'm just going to go across 1. You can see y equals 1 here and here. And there are no points where y equals negative 1 on this blue graph. Perfect. Then the last step is we want to keep in mind that 1 over something big equals something small, and vice versa. So as I am doing this, I also know my x-axis is going to be a horizontal asymptote because this function up here has a 1 on top, so it can never be 0, because the only way a fraction would be 0 is if there is a 0 on top. So in other words, this x-axis is also an asymptote. But where was I? 1 over big equals something small. Again, we're going to keep our x values the same. So you can see on this blue graph, as x comes out to the right and keeps going right, y is getting bigger and bigger and bigger. You can see it's going up. Well, 1 divided by something big is something very small. So as our red function goes out to the right, it's going to get smaller and smaller and smaller and closer to 0. Vice versa here, as it comes to the left, it's going to get bigger and bigger and bigger, because 1 over something small is something big. And the same thing happens here on the left side. So the red function there with the green asymptote is what I've drawn to represent this function. If we follow these steps, these 3 steps here, we can't ever go wrong. So put a vertical so draw the original function first, or the function on the denominator. Put a vertical asymptote through the x-intercept. Keep your points where y is 1 and y is negative 1 on the original graph, and then draw your reciprocal function in, keeping in mind that 1 over a big y value equals a small y value.